Hello again. Sorry, I got cut off. Didn't realize the stream had taken so long. I believe I was just finishing off this last one here. Super quickly, we have our last substance, sodium and chlorine. Sodium is just here in the metal section. Chlorine is over here in the non-metal section. Therefore, sodium chloride has a metal and a non-metal together, just saying that it isn't, or showing that it is an ionic compound. Now, question 9, it says, considering the position of magnesium and chlorine on the periodic table, what is the correct formula for magnesium chloride? Now, this question isn't super easy because you have to work out so for Mg and for Cl, what ions do they normally form? So we're going to look at Mg and Cl and look at where they are on the periodic table. So I'm just going to get rid of all this annotation to start with, just to make things a bit clearer. Assuming it actually works. No, half of it doesn't want to leave. Whatever. Fine, whatever. So we need to look at magnesium here and chlorine just here and work out what the charge of them is likely to be. Now, as I was saying before, and in class a few times, every element wants to have the same number of electrons as the nearest noble gas. So for chlorine, the nearest noble gas is clearly argon. So we're trying to get from number 17 to number 18, the electron. So that's the number of electrons they have. We're trying to get from 17 to 18 for chlorine. So it needs to gain one. So chlorine needs to gain one electron. And if it gains one electron, it's going to go from it's going to go from neutral chlorine to Cl minus. So that is a 1 negative charge. Magnesium, on the other hand, is number 12. And 12 is closest to neon, the nearest noble gas. So magnesium loses 2 electrons to have the same configuration as its nearest noble gas, neon. And if it loses 2 negative charges, it is going to end up with 2 positive charges left over. So magnesium losing 2 electrons, giving them up to something else, makes it Mg2+. So we're going to remember these, Mg2+ and Cl minus, and we're going to go up to our question. Here we are. So Mg2+ and Cl minus. Now the important thing to remember when you're combining 2 ions together to make an ionic compound, we need to make sure that overall the charge is neutral, cancelled out. So for every magnesium we have, there's 2 positive charges, and for every chlorine we have, there's 1 negative charge. Now, if we just had one of these and one of these, so just MgCl, we'd have 1 negative charge here, 2 positive charges. That would end up with a positive charge left over. So 2 positives minus 1 has a charge left over, and we cannot have that. We need to combine appropriate quantities of each of these 2 substances so that all the charges are cancelled out. Now we have 2 positive charges here. We need to have 2 negative charges to cancel out with that. Chlorine has 1, so if we multiply this by 2, we're going to have 2 negative charges to cancel out with the 2 positive charges for magnesium. So if we have 1 magnesium, we have 2 chlorines, that will give us our overall neutral charge, and we can see that works for answer D. Mg2Cl2, that's 1 to 1. That will not work because this is plus 2 times 2, because there's 2 of them. That would be plus 4. 2 Cls would give us negative 1 times 2, which is negative 2, and these do not cancel out. Similarly, this would be plus 4, and this would be minus 1. Those don't cancel out. This would be plus 2 for the magnesium, minus 1 for the chlorine. That does not cancel out. Leaving plus 2 here, minus 2 there for the chlorines, 2 chlorines cancelling out. Hopefully that is clear. Okay, so we're down to the other questions now. I reckon we'll just go straight in. So, question 10. Describe the reason why noble gases don't readily react with other elements. And this is a 2-mark question. So the important thing to remember here is that Reactions, I'll write this out here and hopefully it'll make some sense. Reactions occur to pair up unpaired electrons in atoms, or to result in full, it's probably like and or full outer shells. So the reactions occur to pair up the unpaired electrons. Noble gases already have paired electrons, and full outer shells, so they don't need to react. And that is pretty much it. So whenever reactions occur, it's elements trying to get their full outer shell of electrons, and noble gases already have it, so they don't need to react with anything to get that. Therefore, they don't react. And that would be 2 marks. Okay, so we have, I'm just going to quickly check how long we're going for. Oops. And I'm probably just wasting time, so let's just continue. So this is a set of true or false questions. So it says, state whether the following statements are true or false. An electron carries a negative charge. Now we know that protons are positive, neutrons are neutral, they have no charge, and electrons are negative. Therefore, electron carries a negative charge is a true statement. Okay, so the next one is the group numbers, ignoring the transition metals. So if we go down to the periodic table, when it says the group numbers ignoring the transition metals, it is saying that this is 1, 2, 3, 4, 5, 6, 7, 8, because we're going to ignore the 10 across here. The group numbers ignoring the transition metals. Let's hopefully not delete anything. Represent the number of valence electrons in the atom. Cool. So that I think we know that's true. That's the number of valence electrons is the group number, and the period number represents the number of electron shells. So if we're talking about hydrogen and helium, this row here, they are filling up the first shell. Lithium, beryllium, boron, carbon, etc. are filling up the second shell. Sodium, magnesium, aluminium, etc. are filling up the third shell. And potassium and calcium, at least, are filling up the fourth shell. So it is true in that regard. Now, it technically does fail from here because scandium and a lot of other ones, they do start filling up weird shells. But for the ones that you're going to be dealing with, and for our purposes, that is true. Every period, as we go up the periods, we're increasing the shell number. So we're going to say that's true. Even though it's not 100% true, it is true enough. Now, metals on the right-hand side of the periodic table. We know that the massive left-hand side of the periodic table is made of metals. So this is a false statement. So let's not make that look like a true. Let's make it clearly a false. The right-hand side are the non-metals. So anions have a positive charge. Cations and anions are the names of the two types, the positive and negative. Cations being the positive, anions being the negative. Therefore, if anions are the negative one, they are not the positive one. So this is a false statement. The way I like to remember it is the T in cation looks sort of like a positive charge. There we go. Okay, neutrons have more mass than electrons. So from our first questions earlier, we know that neutrons and protons give the mass. So neutrons plus protons give mass. The electrons don't contribute because they're so light. Therefore, neutrons do have more mass than electrons. That is true.